Alright, welcome back to these Beyond C++ slides. We just finished up Java. We did some cool stuff. We learned how Java likes to use very, very long method names, especially in its standard library. We learned how to make a cool graphical user interface, even if it was just for a counter. It was still awesome. And now it's time to explore the magical world of a programming language called Python. Actually, a lot of computer science departments like to start out their students on Python. At UCSB, where I came from for my grad school, that's what they did. At Fresno State, when I went there, we used C++. So it's kind of a give and take, but a lot of people like to use Python. If you take CSCI 1, I give you a bit more of Python. I like to teach it there. If you need a critical thinking class, please take it with me. So yeah, Python is awesome. Do look into this page. It's a nice little tutorial over all the different cool stuff that Python can do just to get you started. And yeah, take a look at that if you're interested. A fun little comic that came out around the time Python got super popular as a classic these days. So yeah, let's get on into it. Let's talk about Python. It's actually, if you're interested, if you care, it's named after Monty Python, the comedy group, not like a snake. Okay, so there are some puns in places if you install Python that you might learn about. Just keep that in mind. If you've seen Monty Python, it might make some sense. Okay, so I guess the first example for you is a very, very simple program. We're going to write hello world. In Java, it took a few lines. In C++, it took a few lines. You got to make a main function, right? In Java, you have to make a class. Weird. In Python, it's going to be one line of code. Watch this. Vim hello.py. Py is the extension customarily for Python programs. So watch me do this. It's going to come really quickly. Are you watching? That is the program. There is no need for a main function in Python. You can just say print. It's wonderful. My Vim is complaining because I'm not doing the coolest, best readable Python, but this is a program nonetheless. To run it, all you have to say is Python, and then you have to say 3, because there was an older version of Python, Python 2, that was very popular, and so it stayed around for much longer than it needed to, and a lot of people like just have Python. It used to be set to Python 2, okay? Nowadays, just to make sure that there's no confusion, we like to use the version as well. We are using Python 3. It's cooler, okay? It's better. So you just say Python 3, the name of the file, hello.py. Bam. Hello world. Wasn't that nice? That was one line of code. So first of all, there's no main function necessary in Python. You just start writing your program, hello.py, and you can put whatever you want. Print hello. ... That can be your one-line file. Okay, you just start writing code, and to run your program, you just say Python and then the name of the file. That's all. Let me make sure I don't say it here. If I do, never mind. I will say it there. You just say Python 3, the name of the file, and it runs it. Isn't that cool? So, let me show you comments. Comments in Python look like this. This is a single line comment. It's like a makefile comment, isn't it? So, that's a thing. Then there's also a multi-line comment that looks like this. You give 3 quotes, and then you can put as much lines as you want in between. It's like a really long string, again, essentially. This is a multi-line comment. Okay, and you just close it off and it's good to go. And yeah, you run it, it skips the comments, it runs your one line of real code that prints hello world. Isn't that cool? So that's the world's simplest Python program. Let's talk about the differences between Python and C++. So the first one, very, very key, is that I never had to compile anything. There's no Python C or something, nothing like that. It's just give the name of the file and it runs it for you. Python interprets the code. Okay, it has to read line by line. Like, here's a comment, here's a print line, 2 plus 2, print, hi, all this stuff. Python has to read the file line by line, figuring out what you're trying to do, and then it sees, oh, you say print there and some parentheses, I better go compute 4, and I'm going to print that to the screen. It takes a while because it's got to read the file as it's trying to run the program. Okay, so it's called an interpreted language because of that. This is different from compilation. It's like you're shouting out the program as a file, right? It's like you're talking to Python, and it's like an interpreter for the Python language. It's telling your processor what to do based on what you're talking about. Okay, because it's not compiled, there's no machine code. No machine code happens, and so it's a whole lot slower than C++ and Java, like orders of magnitude slower because of this. Okay, so keep that in mind if you ever want to write a very fast Python program. Realize that it's a lot better to write it in C++ or Java if you really care about speed. Okay, the next thing is about dynamic typing. Okay, so let me, I think I called it more Java last time. Let me make a more Python file. And the standard way of naming things in Java is like, it's all about capitals, and when you make a new word, another capital. In Python, it's more about lowercases and underscores. That's how they like to name their things. So let's use that. Here's more java.py. And yeah, let me tell you a few things. The first interesting thing that's probably going to blow your mind a little bit is that Python doesn't care about types. It just figures out the types as they go along. It's got to read the file anyway. What's a little bit of extra work for it? Okay, it's already doing a ton of extra work. So Python will figure out the types for you, and that means if you ever use wrong types, like you try to divide by a string or something, you won't get an error. There is no compilation. You're only ever going to get a runtime error. There is no compile time errors in Python. So here's an example. X equals 2. There is no need, doesn't even exist, to declare the fact that X is an int. It just figures them out. So it knows that X is an int right now. It knows the type of X. There's like a type function that it can figure out the type of. Like, I can say print X, and then I can say print the type of X. It should print int. So it knows, but X is not constrained to be an int for the rest of its life. I can say, X, go ahead and be a string. Python doesn't care. That's not a problem. Oh, sorry, I called it more Java. That's hilarious. Let's fix that. Excuse me. So it's like, okay, yeah, now I'm a string. And then stir is how it calls strings. And it's like, sure, that's fine. That works. Functions, they don't have return types. You just say, you define a function by saying def. Let me show you that. Here's a very simple function that just adds 1. Def add 1, and it gets some parameter, let's call it y. And it just returns y plus 1. Yeah, why not? Def add 1, y. Print add 1, 42. So I'll print 43. That's what it does. It doesn't have to worry about types. This is like, I'm about to make a function, here's its name, here's its parameter, no types, and I'm going to return this. Okay? I also did something else special. White space. White space really matters in Python, whereas in C++ and Java, it was all about semicolons and braces and things like that. If you want to define the body of a function, I have to say that, you have to tab over. You have to introduce white spaces. There needs to be a new column because there are no braces that you use in Python for those purposes. You just say, okay, here's a function, colon, and then here is its body, everything that's indented, okay? Which is weird. Weird coming from C++, but it's a lot more logical. It kind of forces you to write cleaner code, because I'm sure you've made C++ functions where there's no indentation at all, and it's just ugly, but it gets the job done. Python, you can't do that. Okay, so just a bunch of white space, and so that's quite nice. One other common thing is that arrays, while there are libraries that support them, Python's more about lists. Okay, here's how you make a list in Python. Notation for a list. So L is the list 1 to high, okay? And another thing I should say is strings can use double quotes or single quotes. Again, Python just doesn't care. So that's the string high. Okay, and there's my list with things of different types of them, because why not? And these work just like arrays. You can be like print L of 2. I'll print high. Okay. So it's all about lists in Python. They prefer those. They call them lists. What else? I'm just showing you the greatest hits, I guess. Instead of else if, when you're doing an if statements, of course, have colons and white space this time. Instead of else if, for your multi-way if statements, you have elif. They just thought that that was a cool idea, so they went for it. So something like, I don't know, what should we do? I don't know, like a grade calculation. Grade equals, I don't know, 77. If grade is greater than or equal to 90, print A. Elif grade is greater than or equal to 70, print C. And then else print F. Something like that. Something simple. No semicolons as well. It's all about white space. It's a new statement when it's a new line. That's all. Just press enter. So elif instead of else if, that's a key thing, key difference. And it's all about colons. Colons and white space, guys. Colons and white space. So this is a complete if statement. That should print C, right? Simple programs, they run really quickly because there's not a whole lot to do. So those can send like Java and C++ to run for their money because, especially when you're changing a program a lot, it's easier to write a smaller program in Python. And that's what I like to use Python for little small programs that do not too much. Because that ran super quickly. Relatively. I didn't have to compile it, right? Super nice. What else? We're about to make classes, and so I'll show you more about this on the next slide. In a method, when you're making a method, remember how in C++ there's always secretly inside of every object a this? Like inside of a method, there's always a this pointer that points to your current object. It always points there. And then you can get out the fields that way if you override the names. This always exists, and it's secretly passed along. And I remember how in a lab I told you we're going to model classes using functions, and we're going to secretly have an extra parameter, secret first parameter to every method, called self. Python does this explicitly. We have to use self. They actually call it self. That's why I chose that one for our lab. Yeah. Oh no. So we're going to do that. More on the next slide about that. And then Python's libraries are so nice, so much better than C++. Again, Java's are nice, and Python's are also awesome. And probably, I would say that Python has maybe the best libraries out of the three, because you can install new ones, and it's super easy to do that, and a lot of people use Python these days. Okay, it's very popular. So maybe I'll show you a bit of one of the libraries, a cool one. Okay, so yeah, that's the idea. Those are the main key points. Let's make a counter class again, okay? So that I can show you the differences. Okay. So what was I saying here? Indentation is key. you need to explicitly declare self, and the constructor has a weird name. We'll see that. Edit counter.py. Okay, so here's how you do it. Again, it's class. Class is the keyword. And then you say, all right, I'm making a class called counter. And here it is. So colon indent, yeah? And then we're going to make a constructor. Constructors in Python are called, they have a special name, underscore underscore init underscore underscore, okay? That is what its name is. It's a weird one. It's just a special name, that's all. And every method takes an explicit self, not shelf, self parameter first, okay? Though, but it's automatically passed when you call a method. I'll show you what that means when I use the counter class. But let's make our constructor def, and I can say underscore underscore init underscore underscore. And then there's always a self parameter. That's the first one that needs to be there. And then you give any actual parameters to the constructor. And so maybe we can set the count to a special value in our constructor by saying, okay, let's start it at maybe 0. Okay. We can give a default value if the user doesn't give one. Okay, same with C++. And so, what we can do now is we can make a field, and the field gets made in the constructor. All fields get made in the constructor. There's no declaration, again. Python, it's just like you do the thing and it happens. And I've already used count, so I've kind of like shadowed it, right? So you use that same trick that you do in C++. You say, this arrow count, right? But in Python, it's going to be self.count. That makes this right here, this line makes the field. Okay, this makes the field called count, and we set it to count. Okay, this makes the member variable right here. Okay. That's how it works. And so that's a counter class, and that's its constructor. Now let's make an inc method. So normally, the inc method would have no parameters, but because it's a method in Python, we got to take that self parameter that's like a pointer to ourselves explicitly. Okay, it's a reference to ourselves. And so whenever we want to access our member variable, it's always about, we got to go through self. We have to explicitly say, I want my member variable. It's part of me, okay? So you say self.count, and there's no plus plus, unfortunately, in Python. The shortest one is the plus equals. That one's still there. But of course, you could always just be like self.count equals self.count plus 1. That works too. That's always there, of course. So that's inc, and then, of course, we'll need a getter. Def get count. Give this one a try. Let's see if you can do it. Assuming you tried. Now it's self, again as the parameter, and we need to give back self.count. Yeah? That is the idea. Okay, so this is our class. That's how it works. Now let's use it, okay? Let me look at my notes. Yes. We don't need, remember, we don't need a main function. We can just get started, okay? We can just make a new counter, call it C. Okay, this makes a new counter. We don't have to say new, it just does it. Call the constructor, okay? And so here is a good example of explicitly we use self up here, okay? Count is a default parameter. We're just not giving that one. It's going to be set to 0 automatically. There is no talk of self when we actually use these methods, when we use the constructor. Python just passes along, like it's going to make something on its little heap, and it passes along its self to be whatever it needs to be, okay? So we don't have to deal with it when we use the class, but when we define it, we have to include self everywhere. And then you can use it as normal, c.inc, 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 and then it can be like print c dot get count. Yeah, and so this should print 3. Yeah, nice. Let me show you the non-default constructor. We can give an actual value for the count. We'd like c2 equals counter and call it with 42. That'll set the count to be whatever was passed along, or 0 if we didn't give anything. That's what the default parameter does. But here we gave 42, so count's going to be set to that. And then we can increment it like c2.inc a couple times, and now we have 44, right? Oh, sorry, c2 dot get count. Isn't that nice? So that is Python's classes in a nutshell. Quite nice. And before we're done here with Python, I want to show you the coolest library. You can search for any library in Python by just searching on Google Python that library name, but I also included the link here. It works either way. So Python has its own documentation again. And the turtle library is a really fun one that you can use to draw stuff with. Like this code generates this fancy artwork. Okay? So the story behind the turtle library, Python also uses the import syntax instead of like the number sign include syntax. The story is there's a turtle. Yeah? And the turtle somehow got his tail dipped in ink. I'm not going to name any names. I don't know how it happened, but this turtle got its tail dipped in ink, and the turtle also understands English. He can respond to us. We can tell him to start somewhere, put your tail down, and move forward in a certain direction, and he will draw a line on our little page. Okay? Then we can tell the turtle to move in a certain direction, and then go forward, and then stop. We can tell him to pick up his tail and move to somewhere else, like over here, and he won't draw anything. And then we can tell him to put his tail back down and move to another location, and he will have drawn stuff, okay? So we just tell this little turtle with ink on his tail to walk around, and we give him coordinates and directions, and he responds to those. That is the idea of the turtle library. It's a very common thing to use when you're teaching people programming for the first time. It's very sad that C++ does not have a turtle library. This is called turtle graphics. It's used for programmatically drawing things. So I guess let me just give you a quick overview of the turtle library. Of course, you can copy this program. It's really cool. It'll make a nice thing. Let me show you how to make like some squares and some triangles, and we'll call it a day. Okay? So you say import turtle, because that's the name of the library. Turtle example.py. So you say import turtle, and then you tell the turtle what you want to do. The turtle starts out at 0, 0 in the middle of the screen with, I think, black ink on his tail. Okay? So if that's what you want, you're good. Here's what you can do now. You have all these different functions or methods, depending on how you want to think about it, that you can use for the turtle. You can tell him to move. You can figure out where he is and go somewhere else, depending on that. You can tell him to draw a circle, all this cool stuff. Tell him to move forward. So let me tell the turtle to move forward by a certain amount. So here's the forward. You can also say FD. Either one works. So you can say turtle.forward by a certain amount. Before we go, I should also show you the REPL. Dun, dun, dun. Thank you for reminding me. Okay. Turtle starts at 0, 0 facing east. That's how he starts. And so you could say, turtle, Mr. Turtle, please go forward in your current direction by 100. And so when we run this program, it's going to plop open a window. Oh no! It looks like I don't have the right stuff installed. let me go quickly install that because this is very, very fun. Okay? I'm sorry about this. I'll be right back. Okay, I fixed it, and if you're wondering, you have to install this special package on your computer. So, if Turtle doesn't work, use this, oh no, to install the proper packages. Okay, so now it'll work, and we can run it like that. And it worked so fast, and then the window closed, and that was useless. So let us tell the turtle to stick around after he's done drawing. There is a way to do that. One of these, we can tell the turtle to just wait, I think. Let's see here. What's a good one? Screen events, maybe main loop. Dun dun dun. Or done. Either turtle.mainLoop or turtle.done. I like done. We can tell the turtle to wait around. Please wait after you've drawn stuff. Okay, so now I'm going to run it, and I think you can see that the turtle moved pretty quickly. He started there, and he went to the right, because that was his current direction. And so he moved pretty quickly, so let's make him go slower. You can say turtle.speed slow. That'll make him slower and move more slowly. Then what you can do is, let's see here. Oh, that was kind of useless. He's still quite fast, isn't he? I think there's a slowest. We can try that. Dun dun dun. There's turtle.speed somewhere. There it is. There's slowest. Let's try slowest. That was better. That's much more slow. And then he's like he's a triangle right now, which is nice for showing direction, but he's supposed to be a turtle, so we can also change his shape. Change your shape, please, to a turtle. And now this is the dream, right? So we have a turtle, he's moving, and he drew a line. Let's make him draw a square. We can tell him to move. Change your direction, turtle. Please turn left 90 degrees so that we can draw a square. And I think you can see why this is very useful for teaching people how to program the very first time. Turn left 90 degrees, then go forward another 100 units. Boop, boop, boop. You saw him work. It's really nice, isn't it? So, yeah, that is the idea. We can make a square now by turning him again forward, turning him again forward. Let's do that. So twice more of that. And we have a square being drawn. Boop, 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 boop. Isn't that cool? So that's a square, and let's move him like down here a little bit so we can then draw a triangle. And just keep moving him forward, I guess. That'll work. Forward 200 maybe. And the issue is... no. It would help to stop the program. The issue is, if I tell him to go forward 200, he's going to keep drawing a line because his tail is down. So I can tell him to pick his tail up before he moves. Turtle dot. And then once he's in the new spot, we can say turtle dot down again. And then we can start drawing a triangle. So we can say turtle dot... let's see, his direction is going to be down, so let's tell him to move left 90 and then forward 100 again. That'll be like the bottom part of the triangle. Whee, there he goes. And that's a triangle. And so let's just make it an equilateral triangle. Let's keep it easy on ourselves. So that's going to be 180 divided by 3, because we need equal angles, right? So what should we put there? These all need to be the same angle, an equilateral triangle, and they need to add up to 180. I think the answer is 60, right? And so when the turtle's facing this way, we need him to move left by that amount, which is 180 minus 60, okay? Whatever that is, that's the way we want to make the turtle turn. We want to make him turn not by 60, because that's like only going that way. He'll face off in that direction. We want him to turn by 180 minus 60 when he's moving to the left, and then it'll be in the right direction to go forward. You see that? So it's a fun little geometry exercise as well. And it's always in degrees, and then we can make him go forward. There he goes. Yeah, and then we can finish off the triangle by making him turn the same amount and going forward 100 again. So this is a fun little program. You can make it like, I've made games in this in CSCI 1, where you can like hook into key presses and move the turtle in a certain way. The turtle can turn into like a ball, or like a paddle. We can make Pong. It's all doable. It's a fun little library. So we made a square and a triangle. You can change its color. Can be like turtle dot pen color. Make it blue for this one, and I don't know, pink for the first one. And I think that's officially all of turtle we're going to see. So now I have a little pink square and a blue triangle. Why not? Okay, so that is all of the turtle library I wanted to show you. And then finally, something that's really nice for quick math is what's called the REPL. If you just say Python 3, you get plopped into the Python REPL. And REPL stands for read, evaluate, print, loop. Okay? So it's going to repeatedly read some code, evaluate it, print it back out without you having to say print, and do it all over again until you're done. Okay? So that's really nice because you can do things like this. You can just say Python 3, and then I can run some programs like, okay, x equals 42. What's x squared? What is x divided by 2? What is, I don't know, 42 plus 97? Python is really good for that. You can just plop into the REPL, and it's ready to accept Python code, and you can do stuff with it. You can change the variables, of course. X is 42, x equals x plus 1, x is now 43. It's just running straight line Python code. You can also have if statements. If x is greater than 42, I don't know, print yes, something like that. And it prints yes. It knows what to do. It's really nice for like math and things, I think. So I encourage you to use that if you ever feel like it. But yeah, that is Python in a nutshell. It's an interpreted language, so it's reading the program as you write it. It's not compiling it down to machine code or anything like that, which has its advantages and disadvantages, but it's just another tool in your arsenal now, okay? So I think that's all I want to show you of Python. We'll end a bit early today, so that you can work on your final lab. But yeah, I think that's all I have for you. If you have any desire to see Java and Python again, I do encourage you to try to convert some of the programs that you've written, that I've written in class, that you've made in your labs, convert them to Java or Python. It's a really good learning experience to make sure that you're understanding the nuances that each language has compared to each other. Okay, so that is everything that I want to say about not C++. We're going to come back next week and just review for the final. Okay, that'll be all that we do, is just review for the final. So yeah, hopefully that will be useful. Hopefully this was fun. I think we had some fun things to talk about and for me to show you, so I was excited. Yeah, you know a bit more than just C++ now, so you can pat yourself on the back for that. And that is officially all that I have for you. So I will see you next week, and there we will review for the final.